Hello everyone. In today's video, we are going to cover three-dimensional trigonometry. This is a very important topic in IGCSE mathematics. If you check the past papers, you will definitely find at least one question which is based on three-dimensional trigonometry. So apart from this, I have already covered most of the topics in trigonometry, which is Pythagoras theorem and trigonometric ratios, bearings, sine rule, cosine rule. So do check those out as well in my previous videos. For now, without wasting time, let's do some math. In this session, we will cover three-dimensional trigonometry and Pythagoras. Uh, in my previous videos, I have already covered Pythagoras theorem and trigonometric ratios. So if you want to learn that in detail, do check out those videos as well. But for now, let's start with three-dimensional trigonometry. First, we'll revise what is Pythagoras theorem and trigonometric ratios because we are going to use these while solving the 3D trigo problem. So quickly let's check Pythagoras theorem. So in this, when we have base B and altitude, let's say A, and hypotenuse C, so A square plus B square can be written as C square. So this is one formula given by Pythagoras. Second, trigonometric ratios. In trigonometric ratios, we have sine theta, cos theta, cosine theta, and tan theta. So if this is the theta and this is the perpendicular, also known as opposite, this is the base, also known as adjacent, and this is the hypotenuse h. So sine theta is opposite upon hypotenuse, cos theta is adjacent upon hypotenuse, and tan theta is opposite upon adjacent. These are also written like this: sine theta is equals to perpendicular upon hypotenuse, cos theta is equals to base upon hypotenuse, and tan theta is actually equals to perpendicular by base. So we'll use these values, use these formulas while solving 3D trigo. So let's start with, let's try to understand how 3D problems looks like. So let's check. So this is a 3D shape, it's a cuboid. So if you check any face, let's say this one, A, D, H, and E, and if you try to frame a triangle by joining the diagonals like this, you will always get a right angle triangle. So this is a right angle triangle. Or either, let's check, even if you want to join the diagonal AC, then also you will always get a right angle triangle ADC, which is right angle at D because it's a cuboid. So base is rectangle. Even if you join some other side, let's say AG, so even if you join AG, you'll get ACG as a right angle triangle like this. Even if you join, let me check with few more. So for example, if you want to join DF and DB, there also you will get a right angle triangle like this from B to F, right angle at B. So this is how you get right angle triangles in 3D trigonometry, which is used to find the missing length or the angle sometimes. Let's say if you have to find the angle A in this triangle, G, A, and C, right angle at C, and if you have to find this angle, you can use either Pythagoras if the two sides are known to us, or if one angle at one side is known to us, you can use trigonometric ratios to work out the missing length. So this is how we solve problems in three-dimensional trigonometry. Let's check questions. Let's try to practice a few questions to understand this better. So starting from question number 1, it says A, B, C, D, E, F, G, H is a cuboid. Work out the size of angle that AH makes with the plane EFGH. So first, let's check where is AH. AH is here. So first we'll draw the line AH. And now we try to make a right angle triangle like this. So this is a right angle triangle, right angle at F. It says find the angle that AH makes with the plane EFGH. That means this angle. This is the theta that we have to work out. So now we can also see that HGF is a right angle triangle. So using this, we can find HF first, because we already have the perpendicular or the opposite 8. We need either the hypotenuse, this, or the base. So it's easy to find the base because that's itself a hypotenuse in the triangle HGF in this triangle. So we can find the base using Pythagoras. That is, HF is equals to under root of simply 17 square plus 5 square. So let's do this in calculator and get the value of HF. So under root of 17 square plus 5 square, and that is under root of 314. Because this is not the final answer, we'll leave HF as under root of 314. I'll erase this. So this is 314, and we have to find the value of theta. So we have the base and we have the opposite, or we can say we have the adjacent and we have the opposite. So here we'll use tan theta. Tan theta is opposite upon adjacent. Theta what we have to work out. So let's write this down. Tan theta is equals to opposite, that is 8, divided by adjacent, that is 314. So theta is going to be 8. Theta is going to be tan inverse of 8 divided by under root of 314, and substitute this value in the calculator. You will get the answer. So shift tan inverse 8 divided by under root of 314. You will get the answer, which is 24.29. 24.29. But in the question it says write correct to one decimal place. Always check these instructions. So 24.29 can be written as 24.3. This is the angle, so 24.3 degrees, and that's the answer. Let's try another question. Question 2. It says ABCD is a horizontal rectangular field. ABCD. The angle of elevation of T from B is 19 degrees. Angle of elevation of T from B is 90 degrees. That means this angle is 19 degrees. It says calculate the length of AT. So we have to find AT. Let's say AT is X. Give your answer correct to three significant figure. So we have a right angle triangle TAB, right angled at A. So we have to find the opposite length, and adjacent is given to us. So again we can apply tan theta. We can write tan 19 degree is equals to opposite upon adjacent. Opposite is X divided by adjacent, that is 50. So we can write X is equals to 50 multiplied by tan 19 degrees. So X will be, let's check, 50 multiplied by tan 19, and the answer is 17.2 meters, and that's the answer, 17.2 meters. So now let's erase this. We have this as 17.2 and this angle as 19 degrees. Moving on to the next part, it says calculate the distance from C to T. Distance from C to T, so let's mark distance from C to T. That means they're asking us to find this length. Distance from C to T, this. So we can make it a right angle triangle by joining the point A to C. So now we have TAC as a right angle triangle, right angle at A over here, and we have to find the length TC, but we don't have this angle, and we have only one value, that is 17.2, that is 80. We can find AC first. because ABC is a right angle triangle and we have both the values 50 and 27, so we can find the hypotenuse. So AC is going to be under root of 50 square plus 27 square. So let's check what's AC. AC is under root of 50 square plus 27 square, and the answer is 56.82. So AC is 56.82, and now we have to find the length TC. So we can again use Pythagoras theorem. TC is going to be under root of 17.2 square plus 56.82 square, and we'll get the length of TC. Let's check. Under root of 17.2 square plus 56.82 square, and the answer is 59.36. Let's write a correct up to 3 significant figure. So answer will be 59.4 meters, and this will be the length TC, or the distance of C from T. So that's the answer. Let's try one more question. So this is how we solve a problem based on 3D trigonometry. We try to analyze how we can frame a right angle triangle, and then we check out the values that is known to us, either angle or a side or two sides that we can work out, and that is how we find the missing length. Let's try another question. Question number 3, it says the diagram shows a prism. The triangle PQR is the cross section of the prism. Calculate the size of the angle that line MR makes with the plane RQLN. So let's check MR. Where is MR? MR is here. MR makes with the plane RQLN. That means let's join LR. So now you have this triangle as the right angle triangle MLR, and we have to find this angle because it says line MR makes with the plane RQLN. So always this angle, mark this as theta. This we have to work out. But to work out this, we need two sides now, because angle is not known, neither the sides are known. So we can see that the opposite side is ML, and opposite side, this ML will be equals to the side length PQ, and PQR itself is a right angle triangle. So we can find the opposite side length using trigonometric ratio. So here we have to apply, in triangle PQR, we have to apply sine theta, because sine theta will be opposite upon hypotenuse. Theta is 30 degree here, so we can write sine 30 degree is equals to opposite, that is PQ, divided by hypotenuse, that is 20. So PQ will be 20 into sine 30. So 20 into sine 30 is how much? That's 10, because sine 30 is sine 30 value is 1 by 2. So 20 into 1 by 2, that's 10. So that's PQ, and hence ML will also be equals to 10 centimeter. So we'll use this value. Let's say this is 10, but we also have to work out the other value. Now we can see MPR is also a right angle triangle, right angled at P. So we can find the length of MR. MR is equals to, again, under root of 12 square plus 20 square. 12 square plus 20 square. And that's how we can find the length of MR, which is under root of 12 square plus 20 square. That is equals to 4 root 34. Because this is not the final answer, we'll leave the MR value like this for now, and we will not convert it into decimal value, because this is not the final answer. We want to use the exact value so that our final answer is very precise. So here, now we have MR, we also have the opposite side. MR is the hypotenuse of the triangle MLR, and we also have the opposite. So here we can use sine theta again. Sine theta is equals to opposite upon hypotenuse. So opposite is 10, hypotenuse is 4 root 34. So theta will be sine inverse 10 divided by 4 root 34, and that's how the theta value, let's check, sine inverse 10 divided by 4 root 34 and bracket close, and the answer is 25.38, but it says write correct up to one decimal place, so 25.38 will be written as 25.4 degrees, and that's the final answer, 25.4. So do check these instructions in the questions and write your final answer accordingly. Sometimes it is one decimal place, angles correct up to one decimal place, and the other values correct up to 3 significant figure. Let's check one more question. It says the diagram shows a pyramid with horizontal rectangular base PQRS. M is the midpoint. The vertex T is vertically above M, and MT is 15 given to us. It says calculate the size of the angle between TP and the base PQRS. So where is TP? TP is here, and the base PQRS. So basically, they're asking us to find this angle theta. And how can we find this angle? We can find this angle from the triangle TMP. Opposite is known to us. If we find the length PM, from here to here, we can use tan theta, that is opposite upon the adjacent, and that's how we can find the angle in this triangle. And how can we do that? So okay, PQR is itself a right angle triangle, and base and perpendicular is known to us. We can find the hypotenuse, which is PR. So let's find PR first. PR will be equals to under root of 16 square plus 10 square. So let's check the value. Under root of 16 square plus 10 square, which is equals to 2 root 89. So PR is actually 2 root 89. That's PR. In the question, it clearly says M is the midpoint of PR. That means if you want to find PM, PM will be PR divided by 2. So let's check. 2 root 89 divided by 2. That makes PM as root 89. We will not round this up or write it in decimal because again this is not the final value. So we'll write the PM value as root 89. We'll use this and we'll round up the final answer. So now we can find theta. So here we can apply tan theta, which is equals to opposite upon adjacent. So tan theta is equals to opposite, that is 15, divided by adjacent, that is root 89. So we can write theta as tan inverse 15 divided by root 89, and that's how theta correct up to one decimal place. So let's check. Put the values in the calculator. Tan inverse 15 divided by root 89, bracket close, and the answer is 57.83. Correct up to one decimal place as mentioned in the question. It will be 57.8 as the value of the theta, and this is the final answer. I hope you all understood how to solve problems based on three-dimensional trigonometry. All we have to do is we have to figure out and we have to frame a right angle triangle so that we can work out the missing length or the missing angle using Pythagoras sometimes and sometimes trigonometric ratios. So that's all for this video. You can check out more topics like trigonometric ratios, Pythagoras theorem, bearings, sine rule, cosine rule, area of triangle using trigonometry, that is sine formula. I have covered all those videos. You can check out my previous videos and do share it with your friends, subscribe the channel, and that's how I'll keep posting the videos that you want to see further. Do comment in the comment section. I'll definitely reply you back, and if you have any preference of any particular topic, do share it with me. I'll definitely make videos on that. I'm planning to make videos on the past year papers, and I believe it will definitely be helpful. So that's all for today's session. Bye everyone.